Hello everyone. Today in this class I am introducing one of the new chapter, that is chemical kinetics. Straightly I am explaining about this one. Chemical kinetics is one of the branch of chemistry which deals with the study of reaction rates and their mechanisms. Chemical kinetics is one of the branch of chemistry and it explains about the rates of a chemical reactions, that means the speeds of a chemical reactions and their mechanisms. And chemical kinetics, in this one, kinetics is the one word is there. Kinetics, this is the word is derived from the Greek word kinesis. Its meaning movement. And in this class I am going to discuss about rate of a chemical reaction. Rate of a chemical reaction. Now I am explaining about the definition of this one. It can be defined as the change in concentration of a reactant or product in a unit time. The change in the concentration of a reactant in a unit time is called as a rate of a chemical reaction, or the change in concentration of a product in a unit time is also called as rate of a chemical reaction. That is about the rate of a chemical reaction, and it can be expressed in terms of the rate of decrease in concentration of any one of the reactants or the rate of increase in concentration of any one of the products. That is about the definition of a rate of a chemical reaction. Now I am deriving a mathematical expression for the rate of a chemical reaction. I am taking one of the hypothetical equation, that is R gives us to P. Here in the left side capital R is there, it represents the reactant, and in the right side P is there, that represents product. In this hypothetical equation, 1 mole of a reactant R produces 1 mole of a product P. So this was an assumption for deriving one of the mathematical expression for the rate of a chemical reaction. At the time T1, R1 that is placed in a square bracket and P1 that is also placed in a square bracket. So these two are the concentrations of reactants and products respectively. And at the time T2, R2 is the concentration of a reactant and P2 is the concentration of a product, and here they are placed in a square brackets. When one of the term is placed in a square bracket, that represents about the concentration of that term. So here the change in the time I am written, that is delta T equals T2 minus T1, and when the time is changes, the change is occurring in the concentrations of a reactants also. The change in the concentration of a reactant, that is representing here delta R in a square bracket, it represents the change in the concentration of a reactant, that is equals to R2 minus R1. So placed in a square brackets. So that is final concentration of a reactant minus initial concentration of a reactant, and delta, so concentration of P, that means change in the concentration of a product, that is equals to final concentration of the product minus initial concentration of the product. So these are the changes are occurring when the time is changing from the T1 to T2. Now I am expressing the rate of a chemical reaction in this way. Rate of a disappearance of a R, rate of a disappearance of R, that means R is disappearing when the time is changes, that is equals to decrease in concentration of R divided by time taken for the decrease. It is equals to change in the concentration of R divided by change in the time. Here I am written one of the sign, that is negative sign. Negative sign represents the decrease in the concentration of a reactant, and simultaneously there is the appearance of a product. When the reactant concentration decreases, simultaneously the product concentration increases. So I am writing here, rate of a appearance of product is equals to increase in concentration of a product divided by time taken for the increase. It is equals to positive sign, change in the concentration of a P, that means product, divided by change in the time, delta T. So this is about the mathematical expression for the rate of a chemical reaction. Now from the graphs I am explaining the rate of a chemical reaction. So here this is the x-axis, this one is the y-axis. On x-axis I am taking the values of time, on y-axis I am taking the concentration of a reactants. So here R naught, initial concentration, it is present at t equals to 0, and so when the time is changes from 0 to t1, the concentration of a reactant changes from R naught to R1. After some time, so the time t1 changes to t2, the concentration of a reactants changes from R1 to R2. So the difference in the concentration of reactant, that is R2 minus R1, and then change in the time, that is delta T, that means T2 minus T1. So from this we can write rate of a chemical reaction, that is average rate of a chemical reaction, that is equals to negative sign, change in the concentration of reactant divided by change in the time, that is equals to negative sign, concentration of R2 minus concentration of R1 divided by T2 minus T1. So that is about the average rate of a chemical reaction. Now another one I am saying, so instantaneous rate of a chemical reaction. So it can be calculated by the determination of slope. So when the slope is calculated for this curved line, so that slope is equals to instantaneous rate of a chemical reaction. So R instantaneous, that is equals to minus difference in concentration of R divided by difference in the time, that is equals to minus slope. That is about the average rate and instantaneous rate in terms of change in the concentrations of reactants. And in this graph, same kind of average rate of a chemical reaction and instantaneous rate of a chemical reaction I am explaining. So in terms of change in the concentrations of products, so now on the x-axis I am taking the time values, and then on the y-axis I am taking the concentration of products. So at a time t1, the concentration of a product, that is P1. At a time t2, concentration of a product is P2. Now R average, so average rate of a chemical reaction, that is equals to change in the concentration of P divided by change in the time. So that is, so concentration of P2 minus concentration of P1 divided by T2 minus T1. So it is written on the basis of this change. Here change in the time, and then this represents the change in the concentration of a product. And so for this curved line I am calculating the slope. So that slope gives us instantaneous rate of a chemical reaction. So R instantaneous, that is equals to difference in concentration of a P divided by difference in the time, that is equals to slope. So that is about the average rate of a chemical reaction and instantaneous rate of a chemical reaction. Units of rate of a chemical reaction. rate of a chemical reaction, that can be right, rate is equals to minus change in the concentration of reactant divided by change in the time, or rate of a chemical reaction is equals to positive sign change in the concentration of product divided by change in the time. So here in the numerator there is a concentration of reactant or concentration of product. So units for the concentration or moles per liters. So both are the concentrations. There may be reactants or the products. So units for the concentration I am taking moles per liters. And at the denominator which is there, that is the change in the time. So units for the time or the seconds. So that's why now I am writing the units for rate of a chemical reaction as rate is equals to moles per liters divided by seconds. So now rate is equals to moles per liter per seconds. So these are the units for rate of a chemical reaction. So this is about the concept of rate of a chemical reaction. In the next class we will discuss about another topic.